Alright, today's lesson is how to solve and graph inequalities. Now, this is something that you've probably done before in Algebra 1, but in Algebra 2 they get a little bit more complicated and we have these special cases. So we're going to go through some of these step by step. I'm going to just give you a couple easy ones to begin with. First, I want to remind you of the inequalities. Remember, inequalities means not equal to, so this would be our less than sign. Greater than, less than, or equal to, greater than or equal to, and this is not equal to. Special note from back in the day, when you multiply or divide by a negative to solve for x, you need to switch the direction of your sign. We will get to a couple examples of that as these notes go on. So the first thing we're going to do is just take it nice and simple, and we'll start with 5x minus 8 is less than 12. It's just like solving for x. In a regular equation, we're going to add 8 to both sides. We're going to have 5x is less than 20. Divide both sides by 5. And we finish with x is less than 4. So for this class, really, we're not going to ask you to write a whole bunch of tick marks. Basically, all I really want to see is maybe 0, and then you can just go ahead and skip to 4. Now, before you put a circle on the 4 and start shading in one direction, this is the way I teach it in this class, is instead of actually shading on the line, we're gonna just put an open circle above the 4. And a little trick, if you have x or whatever variable first, you always point the direction of your inequality sign when you graph it. I'll show you what happens if you don't in the next example. So we would just draw an arrow to the left. The reason why we're going to do this is when we get to compound, you will I can give you a couple of tricks how you can see it a little bit better. Okay, so for number 2, like I just got done saying, it's easier to leave your variable on the left side. Like I said, if x comes first, when you graph it, you just point the direction of your inequality symbol. Now that I just said that, I'm going to do it the other way, just so you can see what you would have to do in the event that your x is on the right side instead of the left. So what I'm going to do is I'm going to subtract 2x to the right, and I'm going to add the 1 to the left. And we will end up with 2 is less than or equal to 4x, which means 1/2 is less than or equal to x. So when you graph this, of course, we're going to need a 0 and a 1/2. And what you would want to do is you would want to put your solid dot colored in because it's less than or equal to, and you would want to point to the left because that's the direction this is pointing. However, like I said, that only works when your variable comes first. In this situation, we would be pointing to the right because it says that 1/2 is less than or equal to x, which means x is bigger. That's why we're pointing to the right. Or, remember, you can just rewrite it where it's x is greater than or equal to 1/2. It's pointing away from x in this one, so if you rewrite it, you want to make sure that the arrow is pointing away from x as well. Okay, so that's how we solve and graph simple inequalities. Now we're going to step it up a little bit, and we're going to move to compound inequalities. This is where we're going to have an and or an or statement. Now an and can also be described as an intersection or is known as a union. So the first one, it's simple, it's already solved for you. The only thing we have to do is graph -2 is less than or equal to x, which is less than 1. This is called a compound statement, and this is going to represent an and statement. So for this, all we really need to do is put our -2 and 1. Be careful to place them in the correct order. And so here's what I was talking about. So we have x is greater than or equal to a -2. So we're going to put a solid dot above your -2. And since x is not first, we're pointing in the opposite direction. So that's going to point to the right. Now we have x is less than 1. So we're going to have an open circle. X comes before, so this is going to point to the left. So when you have an AND statement. That means that both criteria must be met for this to work. So you have to think of the only numbers that are both greater than or equal to -2 and less than 1. If you want, you can do a few little test points, or you can just remember that if it's an AND statement, most of the time, unless it's one of the special cases we're going to get to, it's only where you have the overlap. So it's just going to be a barbell right above -2 going to 1, and like I said, if you want, you could test it. So pick a few numbers. Pick a -5. Is -5 true for both? No, it isn't. Is 0 true for both? Yes, it is. Is 4 true for both? No, it isn't. So this is our final graph. This red line is actually your final answer. However, when we do these, it makes a lot of sense, and it's helpful to graph each step individually, especially when we get to the special cases. Okay, why don't you try number 2 on your own? It's an OR statement. Let's have you graph it, and then we'll analyze it in just a second. Okay, so we have our -1 and our 2. This says x is less than -1, so open circle above -1, and we point to the left. X is greater than or equal to 2, so we have a solid circle pointing to the right. Now there's no overlap whatsoever, and that's perfectly acceptable with an OR statement because it only has to satisfy one of them. So if I said a number has to be less than a -1 or greater than or equal to a 2, we can have multiple correct answers. We can say -5, which would be true for x is less than -1. We couldn't use 0 because 0 is neither less than a -1 or greater than or equal to a 2, so that's why there's this big blank space in the middle. And then we could say something like 5, which would not satisfy less than -1, but it does satisfy greater than or equal to 2. That's why your OR statements many times will just point in opposite directions of one another. So these next two examples are the same. It's compound inequalities, but this time you actually have to solve for x. So the first thing we're going to do in example number 3 is we're solving for x, getting x all by itself like you would in any solving equation, except for since we have multiple sides, we're going to add 8 to everything first, and this is going to bring us to 6 is less than or equal to 3x, which is less than or this is just less than 18. And now we're just going to divide everything by 3. And we finish with 2 is less than or equal to x, which is less than 6. And we have just solved our compound inequality. Now we just have to graph it. We have our 2 and our 6. X is going to be greater than or equal to 2. X is less than 6. Again, an AND statement, very common to have a barbell, because you are only trying to satisfy what's in between the two, because it must be true for both cases. The only answers you can have are the answers that are between 2 and 6, unlike the OR statement where it can be less than one and greater than another and go on forever and have multiple answers. Okay, so number 4 is an OR statement. Go ahead, pause it, give it a try on your own. And what you should do is solve each equation or inequality individually. So we're going to subtract 3 from both sides first. So 2x is less than 2, so x is less than 1. Or we're solving this one, add 7 to both sides. 4x is greater than 16, so x is greater than 4. So we have our 1 and our 4. X is less than 1, or it can be greater than 4. That means the answers that will not work for this is 1, 2, 3, and 4, or anything in between decimal wise. Remember, an open circle does not mean that it is part of the equation, or in this situation, the graph. The open circle means this is kind of where we're starting. Anything less than 1 or anything greater than 4 with 1 or 4 not included. Okay, so that's solving compound inequalities and graphing them, but those are not the special cases. So here we get to some special situations. And they're already solved for you because I just want to talk about them. Keep in mind this first example is an AND statement. So since this is an AND statement, we're just going to graph it like we normally would. This says that x is greater than or equal to 5. So we have our -2 and our 5. X is greater than or equal to 5. And x is less than a -2. So remember, an AND statement must be true for both situations. So can you think of a number that is both less than -2 and greater than or equal to 5 at the same time? Go ahead, think about it for a second. I'll give you $100 if you can come up with one. Exactly, it can't be done. So since this is an AND statement, the answer is no solution. You can't do it. I mean, if you were to test a few examples, 0 is neither greater than 5 nor less than -2, but try 10. Is 10 both greater than 5 and less than a -2? No, it's only greater than 5. So it doesn't touch the -2. So this is an example of no solution. Here's an OR statement. We have an OR statement that says x needs to be less than or equal to 5 or greater than a -2. Now here's an example of what you would think looks like an AND statement from our regular problems above. Well, in this case, can you think of a number that is less than or equal to 5 or greater than -2? And the answer is yes. Any number you think of will work. Does -10 work? Yeah, -10 is less than or equal to 5. Does 12 work? Yes, it does. It's greater than -2. Does 0 work? Yes, it's actually greater than -2 and less than 5. So any example works. So we just put a line above and just say all real numbers. And our last example is going to cover what would we do if we have two arrows pointing in the same direction. So this again is an OR statement. Since this says x is less than or equal to 5 or x is less than -2, we need to figure out what our final answer is going to be. So obviously they're both true for, or they will both work for any number less than a -2. But what about something like 3? Is 3 less than or equal to 5 or less than -2? And the answer is yes, it only has to satisfy one of them for an OR statement. So your final answer is just x is less than or equal to 5 because that'll naturally take care of anything that's less than -2 anyway. Okay, there's one other one, and that's if they both pointed in the same direction and they were an AND statement, then you would have to pick the one where they both overlap. We have 1 minute and 30 seconds to get through this last question. Remember, I am on a 15-minute time limit for these videos, so if you need to pause or rewind, feel free to do so. So on your way to school, the slowest speed limit is 25 miles per hour and the fastest is 55 miles per hour. All we have to do is write an inequality that represents your speed, provided that you are following the speed limit, and let's pretend that you're going to do the speed limit and you're not going to just drive around at 5 miles per hour. In that case, if you're following the posted speed limit, you would be driving at your slowest of 25 miles per hour, which is less than or equal to your average speed, which is less than or equal to the highest speed limit of 55 miles per hour. Okay, but of course this is one of those problems where you just want to look through the information and write the best answer. I understand that you could decide to just drive 5 miles an hour the whole time, but you know, that's not really that likely. So that brings us to the end of this lesson on solving and graphing inequalities. Have a good one, and we will see you soon.